Thank you. So in the morning we stopped while we were still looking. Please mute your mic. Can you see what I've projected?
Yes.
Thank you. Thank you very much. So we are looking at the properties of the fitted line. We are looking at the properties of the fitted line. So the first one is that the sum of the errors is equal to 0. So we proved this in the morning that the sum of the errors is indeed equal to 0. Then the next one is that, or the second one is that the sum of yi is equal to the sum of yi hat. So the sum of yi is said to be equal to the sum of yi hat. So we are going to look at that. Let me go to the whiteboard so that I can prove this, because we have to prove these properties. After these properties, I'm not going to prove anything. After these properties, I'm not going to prove anything. We're going to solve some problems so that you can rest. And then we'll resume next week. Next week Thursday.
Okay, sir. We are proving only number 2.
No, remember in the morning
Okay.
I proved the first one and the last one. So we are left with 3, which is 2, 3, and 4. So we are going to prove 2, 3, and 4. Is it clear?
Yes, sir.
Thank you very much. So we want to show that the sum of, let me do it like this. We want to show that the sum of yi, I ranging from 1 to n, is equal to the sum of yi hat. So the sum of the actual values is equal to the sum of the predicted values. So it's the sum of.
I would say improve the ratings, please.
So it's the sum of yi. Is it clear now?
Yes, sir.
Thank you. It's yi hat, which is equal to the sum of yi, and we know that yi is nothing but beta 0 hat plus beta 1 at xi. And if we bring in the summation there, we're going to have, because this is a constant, when we sum a constant n times, we'll have n multiplied by the constant plus. So here we have xi and beta 1 is a constant. So we'll have beta 1 out multiplied by the summation of xi. And again, we know that beta 0 hat is equal to y bar minus beta 1 at x bar. So as you can see here, there's n multiplied by beta 0, which means we can multiply this thing by n. We can multiply this thing by n, and if we do that, or let me just do it here. So I will take this one this side. So I will have n into, I will substitute for beta 0 hat by y bar minus beta 1 hat x bar plus beta 1 hat summation of xi, which is equal to, so n multiplied by y bar. Remember I said that y bar it's 1 over n summation of yi. So if I multiply here by n, and I will have to do the same here, then ny bar will be equal to summation of y. So I'm going to do that here, and that will give me summation of yi. Then I multiply x bar with n. It will also give me summation of xi, because nx bar is equal to summation of xi. So here I will have minus beta 1 at summation of xi. So this x bar now changes to summation of xi because I'm multiplying it with n, plus beta 1 at summation of xi. So as you can see, these two will go on a Valentine's date, and then we'll have summation of yi. So we managed to show that summation of yi hat is equal to summation of yi. You are recognized.
So can you repeat to yn times y bar has changed to the sum of y?
All right, no problem. I will do that. The good thing is I cannot see you guys. So when you raise your hand, I don't know who raised the hand. But I do this every day, guys. You cannot expect me to always tell you that why. But please, after class, try to go through these things so that you can understand. This is y bar. If we multiply, let me have a different color. If we multiply y bar by n, if we put n here, we have to do it also on the right. So I will just put it here. So this is ny bar. 1 over n with n will give us 1. So we'll be left with ny bar, which is equal to, because this and this will give us 1, we'll be left with this. So I take this and substitute for ny bar. And then I did the same for nx bar. I substituted for nx bar by summation of xi. You are recognized?
Yes, is it possible to start from the left-hand side? Trying to prove that the sum of yi is equal to the sum of yi head, but starting from the left-hand side.
I have never tried it from the left. As I've said, that every time when I want to prove something, I look at which one is going to be simple, then I take it from that. So it might be possible. So if you can try it, then you might get it right. That's why I said is the procedure. If the procedure is correct, then it will give you the right thing.
Okay, thank you, sir.
Thank you. So we go to the next one, which is I believe that you have downloaded the guide, so I don't want to go back to the properties. I just want to prove it here. So the assumption is that you have the guide. So if you look at the guide, the third one, or the third property, is that summation of I ranging from 1 of xi ei is also equal to 0. And this is from when we differentiated the log likelihood function with respect to beta 1, we obtained something like this. After setting it to 0 and replace the parameters by estimate, we got something like this. When we differentiated with respect to beta 1, we got something like this, and we said this is equal to 0. And if you look at this thing inside the bracket, it's ei, and we have our xi here, xi. So this summation is equal to 0. So we want to prove if indeed this is equal to 0, because we used this when we were dealing with estimating the parameters. So we are trying to to check if indeed this is equal to, it's equal to 0. So that's what we are doing there. So we know that our E, it's nothing but yi minus yi hat. So our E, it's yi minus yi hat. So we're going to substitute here. Let me also, what did I do now? Let me substitute here. So we're going to have summation of n xi. So I'm replacing E by yi minus yi hat, which is equal to, now I'm going to expand this. I'm going to expand this. So this is nothing, xi minus yi will give us the summation of xi yi. Then the summation of xi multiplied by yi hat will give us the summation of xi yi hat. Is it clear? So
Yes, sir.
we have summation of xi yi minus to n of xi. Then yi hat, we know that yi hat is equal to beta 0 hat plus beta 1 hat xi. So now we can multiply this, and if we do that, we're going to have summation of xi yi minus. So beta 0 hat, it's a constant, we take it out. Beta 0 hat is a constant, we take it out. Multiply by summation of xi minus xi multiplied by beta. So beta 1 hat is a constant. You will have summation of xi multiplied by xi. So you will have xi multiplied by xi, which will give us xi squared. So we have xi squared there. Is it clear?
Yes.
You are recognized. There's a hand I'm recognizing. Okay, it's fine. Let me take it down here. I have xi yi minus. I'm changing beta 0 to y bar minus beta 1 x bar multiplied by summation of xi. I is ranging from 1 to n. Minus the last term, which is beta 1 So I have this. Now I can multiply these two terms by summation of xi. And when I do that, I have minus y bar multiplied by summation of xi. Negative, negative, this will give me plus beta 1. There's a hat here. So it's beta 1 hat x bar multiplied by this guy here, which is summation of xi, I ranging from 1. And then we have the last term, which is minus beta 1 hat summation of xi squared, I ranging from 1 to n. Is that one also clear? Is that one also clear?
Yes, sir.
Yes, sir.
Thank you very
Yes,
much.
sir.
Thank you very much. So now, if you look at the last term, we have y bar multiplied by summation of xy. And what is this? Because we can write y bar as 1 over n summation of yi multiplied by summation of x. So this part can be written like this. We can just change y bar and write it like this. And if we do it like that, I want you to pay attention to this. If we do it like that, summation of xi, yi minus this, it's nothing but ss xy. Are you following?
Yes, sir.
Thank you very much. So I'm going to change this. Let me use a different color. So this term, is nothing but ssxy. So I'm going to write that as ssxy. I'm going to write that as xxxy. Let me go back to red. So we have ssxy. Then if you look at this term now, let me change the color. If you look at this term, beta 1, it's a common factor from this side. So I'm taking negative beta 1 as a common factor. So when I take negative beta 1 hat as a common factor, I will be left with summation of xi squared. Because it was plus, this side is going to be negative. Then I will be left with negative x bar multiplied by summation of xi. And this is nothing but what? 1 over n summation of x bar multiplied by summation of x bar. And this is going to give us summation of x bar squared. Is it clear? And if that gives us summation of x bar squared, it means we have 1 over n summation of xi squared, like that. So I'm going to do that here. So I have negative beta 1 hat into summation of xi squared minus summation of xi all squared over n. And if you pay attention, what is inside the brackets? What is that expression inside the brackets? What is that expression inside the brackets?
SSX.
Thank you. Thank you. So we have ssxy minus beta 1 hat ssxx. Now, I want you to follow this. I want you to follow this. We have already arrived. Those who know these things, they can tell that that part is already 0. That part is already 0 because we said beta 1 hat, it's estimated by ssxy over ssxx. So if we make this subject of the formula, ssxy, it means we multiply both sides by this. We are going to have beta 1 hat multiplied by ssxx. So we are going to replace this guy by this, and this, they are the same. They will cancel out, and that will give us 0. Is it clear? Is there anyone who did not get that?
Yeah, repeat, sir.
Yes. I'm listening.
Can you please repeat
Which part?
the last part?
All right, thank you. So when you say the last part, I want to assume that you got this one. So this one is nothing but ssxx. So we're replacing that by ssxx here. Now, we know that beta 1 hat, it's equal to ssxy divided by ssxx. So if we make ssxy subject of the formula, we get that SSXY is nothing but beta 1 hat multiplied by SSXX. So we replace this SSXY by beta 1 hat SSXX. So we replace that by this. And if we do that, we are going to have beta 1 hat SSXX minus beta 1 hat SSXX. And that gives us 0. Are you answered?
Yeah, I'm answered. There was
Thank
no
you.
need for us to put SSXY subject of the formula. Or was there?
Come again?
There was no need for us to put SS.
No, there was no need. There was no need. That's why I was saying we are done with this proof here if you know that this part is equal to 0. So, but I don't want to assume that everyone is following. That's why I had to change I had to replace SSXY by this using the estimate of the slope so that people can see where this thing is coming from. Because I don't want to make assumptions. We had problems in the morning with me assuming that you guys know how to differentiate. So I don't want to repeat that mistake. So we are done with this one. We are left with number 4. And number 4 is saying the summation of yi multiplied by ei, sorry, it's yi hat, it's equal to 0. This is the last property. So that's what we're getting from that property. And this one, it's simple for me, but for you, it's not going to be simple. I will explain why. So let me deal with this so that you can see. Let me deal with this so that you can see. Now, I'm replacing yi hat by this xi ei. And I multiply everything by ei, I will have the summation of beta 0 hat multiplied by ei plus beta 1 hat xi ei. Then I distribute the summation. Beta 0 hat is a constant, so I take it out. We have the summation of ei plus beta 1 hat is a constant. I take it out. I will have the summation of xi ei. In the morning, I proved that the summation of ei is equal to 0. Less than 2 minutes ago, I proved that this is equal to 0. So you have this multiplied by 0 plus this multiplied by 0, and that will give us 0. So it's easy for me because I did this in the morning, and I just did this now. So if you are asked to show this, it means you also have to prove this. You cannot just say this is equal to 0. You have to show it. You cannot just substitute like I did here. I'm substituting because I just showed you that these things are equal to 0. But if you are asked to prove this in a test or exam, you have to show that summation of ei is equal to 0. You cannot just replace by 0. I hope that one is clear. Like I did in the morning when I was deriving the variance. Myself, I knew that the variance of, or the expected value of beta 1 hat squared is equal to sigma squared. It's equal to beta 1 squared plus sigma squared over SSXY. But I had to show it. So it's the same thing. If we say prove this, don't substitute and say because we know. No, you have to show us. Even this we knew that is equal to 0, but I proved it. So we expect the same when you are solving this. If you are asked to show this, is this clear?
Yeah.
Yes.
Thank you very
Yes.
much. So we are done with the proofs for today. For today, we are done with the proofs. So let's go on and see what in the notes. But believe me, we are not going to prove anything again today. We'll see these proofs next week. So we are almost done with chapter 1, because what is left here, it's for us to estimate the parameters using confidence interval. Remember, there are two types of estimation. We have the point estimation, which is what we have been doing, and we have also confidence or interval estimation. So now we're going to look at interval estimation and also hypothesis testing. So we can have a claim that the value of the slope is 2. So we can test that claim using the testing or hypothesis testing procedures. You know the steps. You state the null and the alternative hypothesis. You find the value of the test statistic. You find the tabulated value. You compare if the tabulated value is inside the rejection region or it's greater than the tabulated value. You reject or fail to reject like that. So that's what we are going to do this afternoon. So it's inference in regression analysis. So we, as I've indicated, that we are going to look at interval estimation and hypothesis testing for the parameters. And again, the interval estimation for the mean of y, and the mean of y is nothing but beta 0 plus beta 1 xi. I know that last week we derived the variance of beta 1 hat and beta 0 hat. And now, because we are going to also look at the confidence interval for expected value of y, and also the individual value, which is yi, which is equal to beta 0 plus beta 1 xi plus the error term. It means we also have to derive the variance for the mean and the individual, but that one is not going to help us in the future. So I choose not to derive the variances of this. I will just give you the results of the variance of the mean and the variance of the individual. But if there are those who are interested in knowing the proofs, then tomorrow we have consultation session. Then you can log in early. Then we'll do that together. So today I'm just going to give you the results as they are, and we have a data set and we work on that. Is it clear?
Yes, sir.
Yes.
Thank you. Let me go back to the whiteboard. I always want to write something, so every time I say something, I want to write it so that you can see what I'm talking about. Can you see the board, the whiteboard?
Yes.
Thank you very much. Thank you. So we are going to start with beta 0. We're going to start with beta 0 at which is normally distributed, because it's part of the linear function which is normally distributed. So it is also normally distributed with the mean. We showed this last week that the expected value of beta 0 hat, which is the mean of beta 0 hat, it's equal to beta 0. And the variance of this, we said it's equal to what? Is it sigma squared into 1 over n plus x bar squared divided by ss xx. So we did this, we derived this variance last week. And we can standardize this because beta 0 hat is a random variable. So we can standardize this random variable by subtracting the mean and dividing this by the standard deviation. So the standard deviation of this will be sigma squared into 1 over n plus x bar squared over ss xx. And this follows a normal distribution as well, with a mean of 0 and a unit variance. So this is equal to z. Let me create a space here so that I can write. So this is equal to Z. So the new variable, which is Z, it's equal to beta 0 hat minus beta 0 divided by the standard deviation of beta 0 hat. And this standard deviation is also called the standard error of the estimate. It's the standard error of beta 0 hat. So you must know that the standard deviation of beta 0 hat, it's the standard error of beta 0 hat. But as I indicated, sigma, it's not known. Sigma is not known. And if sigma is not known, we have to estimate. And you saw in the morning that the best estimator of sigma squared is S, which is equal to yi minus yi hat squared divided by n minus 2. So we're going to replace this sigma squared by S squared because sigma squared is the population standard deviation and it's not known. So we're going to replace that. And when we replace, now this takes a different form. It no longer follows a normal distribution, but the student T. If you recall in first year, we have been preaching that it's sigma known. Yes, if yes, go for Z. If no, go for T. So it's the same thing here. Sigma is not known. And because sigma is not known, we are going for T. So I want to erase this and write T. So we have T, which is equal to beta 0 hat minus beta 0. Now we replace sigma by S squared. And you know the formula for S, I've provided you with that. Then we have x bar squared divided by SS xx. So this should be inside the square root. And this follows a student T distribution with n minus 2 degrees of freedom. Now we can test the claim. This is the test statistic. So if there's a claim that, for example, if there's a claim that beta 0 is equal to some value, let's say beta 0, 0. So we can test this claim using this because we have the test statistic, we have the distribution, which means if the test is two-sided, we're going to have 2 alpha over 2, and we have the degrees of freedom. Then we go to the table and look for the theta blended value and we compare. We can test that. We can also, because we need this is the standard error. And when we calculate a confidence interval, we have a point estimate. The formula for confidence interval is the point estimate plus or minus the critical value, which is the value from the table, multiplied by the standard error. So I will just write STD error, multiplied by the standard error. So the point estimate we have is beta 0 hat plus or minus the critical value is T alpha over 2 n minus 2. Then the standard error is here. I can even take this s out of square root, and then I will have, because it's s squared, when I take it out, I will have s plus x bar squared divided by ss x x. Is it clear?
Yes.
Yes.
Thank you very much. Thank you very much. So this is how to find the confidence interval for beta 0, and also how to test the claim about beta 0. Let's go to beta 1. Let's go to beta 1. So beta 1 again is a random variable following a normal distribution with a mean beta 1 and a variance sigma squared over SSXX. And we can standardize this variable by subtracting the mean and divide by the standard deviation or the standard error. So this will give us sigma over the square root of SSXX. And this follows a standardized or a normal distribution with a mean of 0 and variance 1. You are recognized.
You said beta 1 hat follows what?
A normal distribution.
Normal distribution. Okay, sir. Thank you.
Yes, because it's a part of a linear function which is normally distributed. So a random variable, which is part of a linear function which is normally distributed, also follows a normal distribution. So again, the same applies to this. We don't know sigma. Yes.
Oh, I wanted to ask where you were explaining. Can you go ahead? I think I will get it.
Okay. So because sigma is unknown, we have to estimate it. And we estimate it using S. And S is the square root of summation of yi minus yi hat squared divided by n minus 2. So we're going to replace this by S. And when we do that, this now follows a student t distribution. This now follows a student t distribution with n minus 2 degrees of freedom. So again, from here, because now we have the formula, or we have the test statistic, we can test the claim. If there's a claim that there's a positive relationship, for example, one can claim that there is a positive relationship. So we can test this claim using this. The same procedure applies. So it's greater than, it's one-sided. We're not dividing alpha by 2. It's like that. We can also calculate the confidence interval, because as I've indicated that the confidence interval is the point estimate plus or minus the critical value. So it's the point estimate plus or minus the critical value multiplied by the standard error. And the standard error in this case is S over the square root of SS XY. So you can also estimate beta using a confidence interval. So you can also estimate beta using a confidence interval. Is it clear?
Yes.
Thank you. So let's go to the mean. The mean, which is expected value of yi. Xi. So for the mean, we'll only look at the confidence interval. We are not going to test anything here. So I will just give you the formula for the confidence interval. It's there in the guide, by the way, but I will just write it here so that you can see. So that is estimated by yi at some value of x plus or minus the critical value. And the critical value, in this case, again, is also the value from the table. So we're going to have T alpha over 2 and minus 2. And now we want the standard error. And the standard error for this is S multiplied by 1 over n plus this part now changes to XP, or if I'm using P there, let me also use P here, minus X bar squared divided by SS XX. We can prove this, but I'm not interested. I'm not interested in the proof of this. It will just waste our time, because it's taking us nowhere. So this, sorry, there should be a head here. This is the point estimate for this, because this one is estimated using y hat, beta 0 hat plus beta 1 hat xi. So if we know a value of x, we're going to substitute here by the value of x. That's why I'm saying xp. So it means this will be yp. So we replace xi by a certain value, which is xp in this case, then we're going to get a single value here, which is going to be the estimate. And then we write that estimate here, plus or minus the value from the table. And then xp is the value that we're going to substitute here. And then x bar is the sample mean. X bar it's the x bar that you know. But this xp is the
Sir,
value that we're going to substitute in the equation. Yes.
is the Y bar also gonna have a P at the bottom?
Which y bar? Remember, we are
The
not dealing
second
with,
one.
there is no y bar here. This is
Y
y
hat,
at
sorry. Y hat.
y at xp. It's y hat at xp. You can write it as y hat p if you want to write it like that. It's still fine. This is to emphasize that we are substituting the value of x by xp. Are you answered?
Yes.
Thank you very much. So this is what we are going to do when we are estimating the mean, confidence interval of the mean. Now let's go to the last one, which is the confidence interval for the individual. So we have yi, which is equal to beta 0 plus beta 1, xi plus ei. Last week, is it last week or that other week, I said this one is also estimated by this. This one is also estimated by this. So we want the confidence interval for this at xp. So it will be y at or y at is the same as that one of. So the estimate for the individual and the estimate for the mean is the same. So this part is the same as the previous one. The difference is only on the variance or on the standard deviation or the standard error, because that other standard error was just 1 over n plus xp minus x bar squared ss x, and this one has 1, so it's 1 plus this other part. So that is the difference between the individual and the mean. The difference is here. This one is the same. We are going to substitute here, which is y p hat if we want to write it like that, and xp. So this will give us the estimate. And then we find the standard error. So the difference between the confidence interval of the mean and the confidence interval of the individual, it's on the standard error, but the point estimate is the same. Is it clear?
Yes.
Thank you very much. So,
Sir,
yes.
meaning if they ask us a question, they will tell us or estimate one us based on that one of the mean. They will tell us give the confidence interval on a certain point always.
No,
Like
I will be
point.
the one telling you. I will be the one. So address me, because I'm the one who will be asking you that. Don't say they will be. I'm the one who's sitting here.
Okay, sorry, sir. Meaning
Unless you are referring to Mr. Malek. No,
no,
I think it will be clear, because if we say estimate the slope using confidence interval, you know what is the slope. You know how to get a confidence interval of the slope. Estimate the mean using confidence interval. You know that now we are estimating the mean. Find the estimate of the individual. Let's check, we are talking about the marks. So it will be clear that if those marks are, you will see with the example that we are going to do now. You will see with the example that we're doing. So it will be there for you. You will know that now they want the individual. Now they want what? They want the parameter, the slope, the y-intercept, or what, something like that. So whoever is going to ask you, because we are saying are they going to, so they will ask you like that.
It was a mistake, sir. Okay, thank you, sir.
Oh.
Thank you.
Yes. So let's go to the example. Let's go to the example and address these things. Then we'll see if time will allow us to look at the correlation coefficients. I made the mistake here. I should have uploaded this data set on Blackboard so that you can get the sums to simplify things here. Or someone is requesting for a break. And this is the duty of the class reps. As I've indicated that the class reps, after 45 minutes, if you need a break, then you tell me. Then we take a break. Then we resume after 10 minutes. So it's fine. It's now 1:45. We're taking a break, and then at 5:02, we're proceeding. At 5:02, I'm not going to wait. If you leave the session, make sure that at 5:02 you are here. Yeah,
So,
you can take a break.
So while
Yeah.
you're on break, can you bring back the whiteboard, please?
You want the whiteboard? Yeah, you can ask questions if there is something that they want to know. But I also want to at least drink water. So, but you can ask.
Go up, say.
There's nothing. It's not going up here. This thing does not allow me to go to the next page or what. So I always erase when I want to write something new. It's like the board at KB. What?
sir,
Yes. Hey, ladies, please mute the mic. We don't want to hear you. Ladies. Hey, Gideon, please mute the mic. We don't want to hear you. Yes, I'm listening.
can you talk about the previous tutorial? Or another thing?
No, we are not going there. We can only talk about it on tomorrow. Before tutorial, we can do that, but not now.
Okay, it's fine. You can display the
Or you
data
can
wanted
remain,
to display before
you can
break.
remain after this class. You can remain after this class. We'll deal with that. Not now.
Okay, so you can display that data you wanted to display before break.
No, there's someone who asked me, ladies, you cannot do that to me. Now you want me to go to the data and then back and forth.
I thought you wanted to go. Oh, so
Google.
And just imagine someone who did not attend the class and hoping that he or she will follow the recording. Now we are on break, we are talking like this. That person is going to be bored.
That person will fast forward.
Okay.
So there's no way the person will be bored, because even if you're listening to the recording, you also need a break.
Okay. Okay. And you have to get these recordings. They are going to delete them. I think next month I will check the emails. They once sent an email saying that after every 2 months they will delete whatever will be uploaded on Blackboard. So when I upload the guide or the notes, download those notes, because if they delete, it's going to be something else. You will start accusing me of not giving you the material.
How, sir? Aren't you the one who's in control of whatever you upload there?
I'm in control of what I'm uploading, but remember, these things are controlled at ICT. So they can even access this now when we're busy now. They can log in and cancel this class. They have that power to access these Blackboard things. So they can delete whatever I've uploaded on Blackboard. That's why when we give you an assessment and you lie to say no, you were online, it kicked you at around 10 o'clock, they can see that. They can access the Blackboard, get your records, what time did you log into Blackboard, and so they can see those things. So they can also see what I have uploaded here on Blackboard and delete if they feel like it's not good for you, and delete those things.
Ish.
Tepang,
Okay, sir.
welcome. You are here.
But sir, we need a joint strike, students and lecturers to strike against the ITC.
For what?
Sir, they can't remove whatever you post, sir, because
No,
we're
no,
writing
they are
we're
trying to
writing
create,
we're
no,
writing the exam on June.
no, they are creating a space. The thing is, you have attended the class. So why do you still need the recording because you have attended the class? It's like when we're still attending at TC, then you have attended the class, there was no recording there. If you attended the class, you are covered. So, but they are doing this to create a space. I think they have a very good reason, a very good reason why are they deleting. So it's not like they are fighting with us or something like that. I think they are creating a space because if they don't delete this, I don't know. They remember you did computer science. They buy these things, so maybe they bought. I don't know the space they bought, but they have to create space for other things, those kind of things. It's like when you have a USB and it's full, you always go and delete that. I don't want to mention it. You delete and load another one. So it's always like that. So you always go and delete, you load another one. So it's the same thing. They are deleting to create a space, then we load another one.
They should save these things on cloud so we can get them there.
Now you are giving me the responsibility to go and talk to them. You delete the movies that you stored in your USB. So you delete those movies, you get another ones, and then when you are done watching, you go and download another one like that, or you go and
No, sir, I don't delete them, sir. I go to
How
a
do
friend
you
who has
download those
space and then
videos?
put them.
Because you can't download them.
what? Manyama.
The age, I've been struggling for 2 years to download these videos.
Manyama.
I'm saying, how do you download the videos? Because I can't download the videos.
You can ask your classmates. I think there is a way of downloading. I have never tried because myself I don't need these things. So after class it's like it's done. But I can check that if you want to have them. I can check that for you. So
Just use Opera Mini.
there is someone who's saying they're using for revision. The thing is, I don't have control. Like I said, it's the message from ICT. So they were just notifying us to know, and I'm sharing the message with you that if it's possible, download this because I'm not the one who's going to delete. And they are doing that to create a space. Otherwise, we are failing. We are going to fail to record the coming sessions. So the best way is to delete the previous sessions to accommodate the new ones. That's the message they have communicated. So it's not me who's going to delete, but we'll discuss that after class. Now it's time to go back, as you can see the time there.
Yes, sir. We were not fighting you, sir. We were just
No, I
pushing
understand. I was
back.
also just saying, I understand. I know that you guys will never fight me. We are friends here. We are family. So let's deal with this. Let's deal with this problem. So we have the data set. You remember this? I've been giving example with this since day one. You have the number. We have the number of books someone used. So we have number 1, 2 up to 40. So student 1 there is it's Homo, for example, who used 3 books to prepare for an exam, and he obtained 56. Then the student B there used 1 book but obtained 57. So that is what is happening on that data set. We have someone who did not use a book depended on the notes that I'm providing, and that one person got 45 and so forth. So we are going to estimate the betas, beta 1, beta 0, then we interpret them. We'll also look at the variances. We estimate the variance of beta 0, estimate the variance of beta 1, then we can also construct a confidence interval of those betas. We can also construct a confidence interval for the mean, a confidence interval for the individual. So it means we need the variances of those estimators. So now, you know the formula for calculating beta 1. It's SSXY divided by SSXX. So as I've indicated that I should have provided you with this data set. So what I'm going to do now is to make this clear that these are the values of X and these are the values of Y. And what we need here, it's X squared. If we can get X squared, which is this value squared, then we can have the sum of these values squared. So 3 squared is 9, 1 squared is 1, 0 squared is 0, 2 squared is 4. So these are the values of X squared. So we can also get the values of Y squared. We can also get the values of Y squared. So we take the value of Y and we square it. And the first value there, which is 56 squared, is going to give us 3136. You can do this with a calculator, by the way. You can get these sums from your calculator. You know how to use a Casio calculator. And the last one that we need is XY. So the product of X and Y. That is the product of X and Y. So it's 3 multiplied by 56. And that gives us 168. So we have those values there. So let me highlight this so that you can see what is happening. Bold, and also change the font size. So this is what we are having. We're having the value of X, the value of Y, X squared, Y squared, and XY. So as I've indicated that we have 40 values. As you can see, the last person, that's number 40. Now we need the sum of these things. We need the sum of these things. So let me use this one. Auto sum. Then I need the sum of that. Sorry. So I need the sum of this, and that is the case. So I can also get the sum of these other ones. So remember the order here. It's X, Y, X squared, Y squared, XY. So it means these values, can you see what I've projected?
Yes.
Yes.
Sir.
So it means these are the sums. You can get this from your calculator. So it means these are the sums. Now we have the sum of, write these values down so that you can see when we are calculating. We have the sum of Y, or let me also write them down so that I can take this to the board. because after this, I no longer need this. So you can take those values. 80 is the sum of xi. 2553 is the sum of yi. 240 is the sum of xi squared. Then 1, which is 137,539, is the sum of y squared. And we have 5,543, which is 5543, which is the sum of x, y. So I want to take this to the board so that you can see when we are writing. I want to take these values to the whiteboard. So please take those or note those sums there so that you can see. Or you can also do this on your calculator, but you don't have the data. So immediately after this class, I will provide you with this data set. So let me go back to whiteboard. Let me go back to whiteboard and give you those values. So we are here. We have sum of xi. I is ranging from 1 to 40, and this is 80. Then we have sum of yi, I ranging from 1 to 40, and this is 2553. Then we have sum of x multiplied by y, and it's 40, and this is equal to 5543. And we have summation of xi squared, which is equal to 240. Can you see what I'm writing? And the
Yes.
last one, thank you, which is yi squared, which is 173539. So these are the sums that we got there. I did this because it will help us to get everything that we want. You can also get x bar if you want x bar from there, but since we have the sum of xi, you can just divide 80 by 40 and you get y bar. So we estimate beta 1 first, beta 1 hat, which is given by ss xy divided by ss xx. And this is nothing but the summation of xy minus summation of y, summation of x over n. You saw this from the previous proof. And this one is nothing but summation of xi squared minus. Please substitute the values here and give me the answer of beta 0. Substitute the values. Summation of xy is given, it's here, it's 5543 minus, you substitute here as well, and you give me the value of beta 1. Please press your calculator and help us with the values so that you can, at least you have done something today. Please give us the value there. You just substitute, the values are given there. You just substitute here and give us the.
I'm getting 5.463.
Thank you. So it's far. Sorry. Are you all having this value?
Yeah, 5.46.
So this one I'm told is 5.4625.
Great.
So this is the value. Yes. I'm listening. Is there a question? I want to believe that you have written these values down, because I'm going to erase them so that we can calculate beta 0. So please write these values down so that we can proceed. I'm listening. There's someone who wanted to ask a question.
No, so I was saying 5.463. It's like I rounded it. There's nothing wrong.
I don't round anything. Don't round anything here. Because these things of rounding will cost you. Don't round anything. These things of rounding will cost you. Don't round anything. So let's go to beta 0. I assume you have taken down these values. Let me just erase everything so that I can create a space as well, like the ones in Blackboard we just delete and to create a space. Or what you also do in your phone, you delete all the pictures to capture new ones. So I'm doing that. So beta 0 at it's y bar minus beta 1 at x bar. And we're given y bar is nothing but 2553 divided by 40 minus this value we just calculated it, and you said it's, I don't want to round anything, so I will write it as it is, divide by 80 multiply by x bar, it's 80 divided by 40, as you can see there. And what is the answer?
I'm getting
52.9.
I'm just 52.
It's 52 point what?
It's
Something is not
52.9.
right.
0.9, yeah.
I said don't round anything. Don't round anything. Don't round. If you round these things, we will give us wrong values. So don't round anything. So this is what we are having. So we have beta 0 and beta 1. Now we can estimate our model. Y I had, it's now equal to 52.9 plus 5.4625 multiplied by xi. So this is our model. This is our fitted model. This is our estimated model. So what is the meaning of this? So if you are recognized?
Sir,
Yes.
hello, sir. Is
I'm listening.
473 over 80. Is it our value of B hat, 1 hat?
Yes, it must be the value of B1 hat, yes. Unless I made the mistake somewhere there, please correct it if I made a mistake.
It's 437.
Thank you.
Sir,
Thank you.
myself,
Yeah.
I'm just
It's
getting 50.
437.
Yeah.
It's 437. Thank you. Thank you for that correction.
Yeah.
All right. Thank you. Thank you for that correction. But the other values are correct, right?
Yeah, they are
Yes.
correct. They
Yeah.
are correct.
So I'm saying, what is how do we interpret now this value 52.9?
Is the y-intercept when x is 0.
What is the meaning of that? I said you should always relate this to the given problem. You cannot just say it's a y. You didn't. I can see it's a y-intercept. What is the meaning of that? It's like saying we calculate standard deviation and you say interpret, you say the standard deviation is 2. We can see the standard deviation is 2. What is the meaning of that 2?
Is the mask of a learner who did not have a study book, but what?
Yes. Yes. Thank you very much. So on average, a student who did not use a book to study, so x is equal to 0. Student did not use a book, is expected to obtain around 52.9. And what is the meaning of this? 5.4625.
Can you come again, sir? On the mean. the mean 52.9.
52 is the value of y when x is equal to 0, but we want the meaning of that. So if x is equal to 0, it means what? The student did not use any textbook. So that student is expected to mark around 52.9. Is it clear? Now, what is the meaning of the value of beta? These things are there in the guide, people.
It tells us already the mask will increase by 5,4625 when one learner uses
You
one.
will eat after, please. You will eat after, please. Tell us that. So the mark will increase by this unit if we increase the books by 1. So when you add a book to the number of books that you are reading to prepare for a test, then the marks will increase by this value. So we are saying if you were studying using 2 books, now if you add another one to be 3, your mark is going to change by 5.46. Of course, if you read and understand, but if you read 3 books and you don't understand, then it's something else. So that's what we are saying there. That is the meaning. These things are there in the guide. I don't want to follow that definition that is given in the guide. I want you to understand what is happening here. So beta 1 tells us how the value of y will change if we change the value of x by 1. So if the sign was negative, it was going to tell us that the marks will drop by this margin. I will recognize you. Can I please finish? So if the sign was negative, we are going to talk about the marks dropping. But because it's positive, it means there is a direct relationship between x and y, or between the number of books and the marks. So those are the things that you must get from this equation. You are recognized. Someone wanted to ask a question. I'm recognizing that person.
Sir, I wanted to just clarify my answer. If I just wrote the mark will increase by 5.462 per book.
SSXX. And you know what is our S? Our S is SSYY minus beta 1 hat SSXY divided by n minus 2 all over SSXX. And this is going to be equal to, so for this, we have to calculate this first, which is summation of yi hat, summation of yi squared minus summation of yi all squared divided by n. And this is going to be 173,539 minus summation of yi squared, we said, is 2,553 all squared divided by 40. And what do you get there? Press your calculator and help us with the value. Okay, so you still with Malu.
Yeah, we are still here, sir.
With you.
13475. 1734.
Come again. 1734.
75.
Let's start. You are breaking. I don't know if it's my or yours.
Ah,
You're
it's
saying
my
it's
network. 7.
You're saying 17.
Yeah. 34.
34.
75.
75. No,
Comma.
no. Something. 75, comma.
175.
175. Are you all having this value?
No.
No,
What
sir.
are you having?
I also familiar with it.
What are you guys having?
We have
If you got the square root,
10592.
No, the square root is there. Maybe it's not visible from your side, but I said it that squared. So if you were listening, you would know that I squared that value. Not to say I'm protecting myself, but I said it. So the answer is 10593.775. Is this correct?
Yes.
Yes.
We are replacing this by 10,593.775. So because here we are going to the SS. So the best way is to find the value of SSXX to avoid finding SSXY and then we come back and find SSXX. So it will waste our time. So let's be smart and only calculate SSXX. And we have already calculated it when we were looking for beta 1 there. You calculated SSXX and you obtained it to be 8. You can confirm if it's still 8, but myself, I know that it's 8. So now we can now come here and substitute. This one we just calculated is 1053 point, sorry. Let me create a space so that I can. You can confirm that one of SSXX, but it's 8. So I'm going to substitute here. This one is 10,53775 minus beta 1. And our beta 1 we said is 437 over 80 squared multiplied by 8. All divide by, we have to divide this first by 40 over 40 minus 2. Then we divide this whole thing by 8 again. And what do you get? What do you get? If you don't understand, feel free to ask.
2,995 blah blah blah.
Sorry, it's
2.6
what?
2.6995.
995 and so forth, as you said, blah 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 blah. So are you guys all having these values? Are you guys having this value? So these things are simple. I just wanted to show you how to plug in these values in your calculator. So what you need is to get the sum.
Sir.
If we have, yes.
Now the network cut me out, so I didn't know what we were calculating here. But
We're calculating the value of the variance of beta 1 hat. So the first thing to do is to find the value of S using this formula. Let me use a different color. So using this formula, we had to find the value of S. Then after finding the value of S, we divide it by SSXX. And someone said is this. So I'm asking if you are all having this.
Yes.
Thank you very much. So now because you have this, you have the value of beta 1. I don't want to erase because now we have the value of beta 1 plus or minus. This one is simple, we can get from the table. Then we have our S over, this is S squared, sorry. We have our S over the square root of SSXX because it's going to be the square root of this value. So this part is the square root of this, and that will give us the confidence interval. So it's simple like that. It is simple like that. So what you need to understand is how to get these summations of xy, of xi, yi, xi squared, and don't memorize, as I've indicated, that you don't know how the data set will be presented. So you have to know all these expression that SSXX can be written like this, SSXY can be written like this in all angles, because you don't know how the data set will be presented. You don't know that those people whom was referring to saying they will. You don't know how are they going to present the data to you. So don't memorize and say, no, I'm going to learn or master this route of doing off. You don't know what's going to happen. So please don't memorize these things, understand them. I want to run the results of these things to check if the values that you were giving me are correct or what, because I can see Tom is not on our side. So I want to run this from Excel and check. Yes?
I wanted to ask about alpha. Do we use 0.5?
If alpha is not given, it's 0.05, it's 5%. But if it's given, then you know what to do. So in this case, because it's not given, you use 0.5. But I mean, you use 5%. But if it's given, you know what to do.
Okay, thanks.
Is it clear? So
Yeah.
I want to run what do we doing? Let me just project this. Tell me if you can see it. Can you see the data set?
Yes.
Yes.
So I want to confirm the values of beta 1 and beta 2, and also the variance of beta 1. So I want to confirm those. So I want to confirm those values, and then we call it a day. I send you this data set. Then now I also want the confidence interval. Then I want this as well. Don't know what happened there. Let me deal with this first, because the x values are here. So I can run this, and here are the results. So if you can see, the intercept, which is beta 0, the value of beta 0 is there. It's 52.9. So that one is correct. and the value of beta 1, which is the value of the x variable, it's 5.4625. So even that one is correct. So there we were spot on. You are recognized.
Hello, sir.
Yes,
Hello.
I can hear
Please
you.
repeat how you got the ANOVA thing.
But I'm still explaining. I will do that when I'm done with this. I will do that when I'm done with this. So
Okay, thank you.
now, yes, I will do it. Be patient. Don't worry. I will do it for you. Now, you said you have 2 point something. It means when we square this value, we have to get the 2 point something that you gave me. So I will just do it here. It's equal sign this value squared. And it's correct, as you can see. It's 2.6995 something. Do you see it?
Yes.
Yes.
Yes, thank you. So because of time, I opted to do it like this. But you can press the calculator as someone did, because these values I was given there to show that it's possible to get them. So please go and try these things, and we will take it from there next week. But we do have tutorials tomorrow. We do have tutorials tomorrow. So let me repeat for someone who asked me to do this. But by the way, we're still going to do this during the practicals. Just that I doubt we will be using Excel. So we'll be using SAS and SPSS to do these things. So, but let me do it for that one person who said I should. And don't memorize this, because I will never give you the data set like this and say do. I know you will use the system or the calculator. So I won't do that. So let me start. So what you do, you go to, there's file, home, insert, page layout, formulas, and data. So you click data. Then top right side there's data analysis. You click data analysis. There are a lot of options here. We are doing regression. You select regression. Then there are options. The first one is input Y range. So you select the values of Y, all of them. You select the value of Y, all of them. You go back to Xput. You select the values of X, all of them. Then you'll choose here. If you want a confidence interval, you also tick in confidence interval. The labels there, if you look at the data set, there's books. Books is the X variable. But because I did not highlight it, I did not click the labels there. But if it was highlighted as well, I have to tell the system that the first row is the labels of the columns. So because I did not highlight them, I'm not clicking that one. Then there's output range, where I want my results to appear. So you can choose a new worksheet ply, or you can just say an output range. Then you place the cursor there, and then you choose where you want your data to, your results to appear. We are not done with residuals. Chapter 2 is about residuals. So when we get to chapter 2, we'll also entertain these options down here of residuals and so forth. So now we are not yet there. That's why I did not entertain. And you press OK. So when you press OK, let me take this to a new sheet. So if I take a new sheet and then I press OK, then I will get my results on a new sheet, which is sheet 2 here. And the results are the same as the ones displayed earlier. Is it clear?
Yes, sir.
Yes. Someone is saying, why can't we also use Excel? You can use it if it's allowed in the exam room. But even if you are going with Excel, I'm not going to give you the data set like this.
What kind